Hello all-nighters, now we will discuss a DFA for the language of strings which ends with 110. Just like in the same previous example, the input alphabets are just 0 and 1. In W, the strings accepted are ends with 110. The most basic string is 110 as I said in the previous video, and then followed by can be anything, but it should end with 110, 0 110, 1110, 0011, so on. Now here initially it will take a Q naught state and the most basic string is 110. So on 110 it should go to final state. This is the skeletal version. Now we'll build upon it. Next 0 1 1 0, 0 1 1 0, because after this on computing after computing 0 we should check all the three digits, those are 110, because it is not in the middle of 110 or anything. Next 1 1 1 0, 1 1, and we have two more digits, 1 and 0. Here think of it as like this is the example, right? Up to here we have completed these two digits, we are left with 1 0. Now ends with 110 and the previous digit is 1, so we have already checked the first one and we should check the second one. After checking the second one it should reach to Q2. After checking the second one it should reach to Q2. So after this second one it should reach to Q2 itself, so it will be a self loop and it will reach here and followed by 0 it will go to the final state. Next 0 0 1 1 0. Now we should build upon this as like for every state it should have a transition on every alphabet. So Q0 on 0 we have a transition, on 1 we have a transition. Q1 on 0 we don't have a transition, so we'll construct it. Q1 on 0. See, if it reaches to Q1, that means the previous alphabet is 1. So after 1 we are getting 0, which is useless, and we should check the 110 from the starting. So on 0 it will reach to Q0 states itself. Next on Q0 Q1 we have for both 0 and 1, and Q2 on 0 and 1. Next we should build upon Q3 on 0 and Q3 on 1. See, to enter the Q3 we have the previous symbol as 0. So Q3 on 0 we should check all the digits. So we'll go back to the initial state. Now Q3 on 1. After we get 0, we got 1. Q3 on 1 implies. So first one of 110 is checked. So we'll move to Q1 state, because at Q1 state first one is checked. So this is simply the whole thing. Now to finish, you should check that everything has a transition on every state. Every state has a transition on every alphabet. So Q0 on 0 we have, on 1 we have, 0 we have, 1 we have, on 0 on 1, on 0 on 1. So this is the complete finite DFA for the strings ending with 110. Here the set of states are, this is the tuple which we discussed in the introductory video of DFA, Q0, Q2 and Q3. And next this is Q0 is Q0 itself, it's the only initial state available, and the final state is Q3. Now these are the all the tuples, and the other tuple is a transition function which you can draw easily, transition table. Now let me explain the transition function of DFA with this example. I said this transition function is Q cross sigma gives rise to Q itself. That means on every state with every input alphabet it should reach only one state. But suppose take any state Let us suppose Q1. Q1, Q represents set of states. It can be any of the states on any of the symbols, on any of the input alphabets. It should reach only a single state. See, Q1 on 0, it is going to Q0, and Q1 on 1, it is going to Q2. Simple. The logic is it should go to only one state on every transition. On every transition of set of input state and an input alphabet. That's the explanation of this thing. Transition function of DFA. That's it. Thank you.